Welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Tonight we're going to be looking at object-oriented programming in Python, and to achieve that we're going to use classes. Object-oriented programming is a feature of Java, really. Java forces you to be everything has to be object-oriented. You always have to use classes, and it's quite a disciplined way of programming. Python's a lot more free-form. You can just write code and use objects when you want to, but sometimes the discipline of Java really can improve the layout of your code and make it easier for multiple people working on the project. So while I go through tonight's session, you can write comments in YouTube and also on our Slack channel, so in this Learning to Code channel of Beginners Python. So I'll be watching those two places for questions, and so feel free to ask. I look forward to getting questions. This is a live session, so that's one of the big advantages of a live session, is you can ask questions as I'm going along. So we're going to use Google Colab, which means you don't need Python installed on your computer. So let's so there's a link to Google Colab just below the video that you're watching, and I've also got one here on the meetup page. So if you click on that link and open it up in a new window, you probably want a new window, so otherwise you'll lose the video, and you'll get the Colab notebook, which is a Jupyter notebook. Now see, it says here changes will not be saved, so I recommend you click on copy to drive, and that way you'll be able to make changes and save them to your own Google account. If you don't have a Google account, you won't be able to do that, so I'll just open that in a new tab. But you won't be able to save them if you don't have a Google account, but you'll still be able to run them. Okay, so these notebooks, just briefly run through, they're just made up of cells of text. So here's some nice formatted text. I've given you a few links in it, including to our GitHub site, where I'll be putting a copy of this session up there, and you can look through our past sessions to see what other topics we've done, and that'll also include links to the videos that go with them, and so you can watch the videos and run them again. You won't be able to ask questions, of course, because they're all pre-recorded. Okay, so that's a text cell, and then we've got some Python cells down here. And to run a Python cell, you can see there's a play button in the left side. You can click on that, or you can see you can do Control Enter, and that will run the cell. Now, to get started, we need to we need to connect to a new runtime, so I'll just click the connect button up here on the right, and that will Google will allocate us with a virtual private server to get going. Okay, so I'm just going to run this first cell. It's just going to import a couple of standard libraries that we're going to be using tonight. So you have to run it, otherwise you won't be able to use them. Okay, so let's start off. We'll have an example of an object. So most things in Python are in fact objects, even though they don't make a big thing of it. So let's look at the data type of complex. So a complex number has got a real part and an imaginary part. Imaginary part being the square root of -1, which of course can't really exist, so that's why you have to imagine it rather than seeing it for real. So to create a complex number in Python, they've got this very succinct notation. You just use the J symbol. So it's something plus something with a J after it, and then Python knows that's a complex number. So if I run that cell, it'll say, it'll print out what C is. C equals 3 plus 4J. That's our complex number. So it's 3 is the real part, and 4 is the number of times the square root of -1 we've got in our number. We can call this function type to say what type is our piece of data that we've got, and it tells us it's of the class complex. So class is telling you that it's an object. Every object has a class. And then there's this function here, repr, which is how do you represent this number, and it's just representing it as a string in a way that if you passed it, in a way that you could use that in your code to create that number. It's not always exact, it just depends on how the person who wrote that class has implemented REPR, but that's the general objective of REPR. So one of the things about classes is you want to know what type they are, and there's two ways of doing that. We've just seen the type function, and the other one is instance, and we'll go through what the difference between those two is later. But we want to see, is our variable stored in the value C, is that a complex member of the complex class? So let's have a look at that, and the answer is true, it is. Now, objects in classes, they have attributes, and you can access the attributes by using the dot notation. So c.real and c.image are the two attributes of the complex class. So it's a little bit more succinct than using dictionaries to store data. In fact, even though dictionaries are more like JavaScript objects than classes are, I've seen people in coming from the JavaScript world who really like the dot notation that JavaScript objects have for accessing the values inside the object, to use classes rather than dictionaries. And you can just say c.real. So let's create a new code cell here, and we'll just do that. So if I type c.real, it tells me the value of that attribute is 3.0, and so that's what I've done in this f string here. Now I've used f strings quite a lot through this, but you can also just type the value, because it's IPython, interactive Python, the last row, the last line in one of these cells. If it evaluates to a value, it will then display the value below it. So an object has attributes, and the attribute can be data or functions. We've seen two pieces of data as attributes, but you can also have a function. The function you would call by using the dot notation. So for example, complex numbers have a function called conjugate, so you could call that function by c.conjugate, and then the parentheses to say I want to call that function. Now when you've got a function that's on an object, that's the name for them is methods. They're called methods. You don't need to know that, but if people are talking to you about objects, then you can say this is a method for that object, which is just a function that runs on that object's data. So let's have a look at what the conjugate of C is. So if C is 3 plus 4j, then the conjugate is just 3 minus 4j. So when you want to create an object, sometimes Python has built-in ways of creating the object, as we've just seen up above. I could just type 3 plus 4j, and that will create a complex number for me. But if it's not a built-in type, then you can create the object by calling the class name as a you put down the class name, and then in parentheses you put the data that's going to create that class. So for example, if I wanted to create a complex number, in fact the same complex number, using this notation, I can put the class name, which is complex, and then I pass in the arguments, which are just numbers, and they'll be the real and imaginary parts. And there we get C equals 3 plus 4j. Well, we already had C as that, and then C2, the new one we've created, is also 3 plus 4j. And we can do an equality test on them. It does C equals C2, and that results in true. Okay, so let's create a class. Well, the simplest class that you can create just does nothing. It's got a name, and we just put in front of it the keyword class. So you can see that's colored blue because it's a keyword, and that defines a class. Now, and you put the colon at the end. Now, in Python, when you put a colon at the end, it goes, all right, I'm about to start a code block. You better put something in the code block, and it can't be just a comment. So we don't want anything in there at this stage. We just want a class that does nothing. So we'll put in this Python keyword pass, which does nothing. So that's our do nothing line in Python. So I run that. Now I've defined my simple class. Now we get rid of that. All right. Now I can create instances of that class just by using the class name and parentheses. Now you see, when we had variable names, we keep them all lowercase and we separate the words in it by underscores. And that's just a convention, but it's if you keep to that convention, everyone will be able to read your code a lot more easily. When you're doing class names, the convention is to do this title case way of writing the name. So every word gets a capital letter and there's no underscores in it. So that's why I've called it my simple class with a capital M, capital S and a capital C and no underscores. So let's create our object MSC instance. Is the name of our variable, could be anything, and we've now got one, and it basically does nothing, it's just a class. But with a class I can create new attributes on it using that attribute notation with the dots. So if I say MSC instance.a equals value a, then it'll create an attribute, call it a, and store this value, whatever it is, in this case it's a string, in that attribute that I can then look at later. So let's have a look at that, and I've decided to use an F string with the exclamation mark R, which calls REPR of that value, and it says the REPR of my simple class instance.a is value a, which is exactly what we put in it. So that's the class. You've created a class. You can now do some object-oriented programming. So let's look how we'd say define a class that did everything that the complex class is that we did before. So remember, complex class before had a lowercase c on it. So we're going to create a class with an uppercase c because that's really the way you should be doing classes, with title case. So we'll define a class. We'll call it complex, and then we'll just inside the class, so you can see it's indented, we'll define a few functions. We'll define this one called double underscore init double underscore. We'll have one called double underscore str double underscore, and one called conjugate. So if I run that cell, I've now defined the class, and now let's do some things with it. So remember before, with a lowercase c, we created an object by passing in two arguments. This time we'll pass in 5 and 12, and we get, I wish that wouldn't keep going up. We get 5 plus 12j is our complex number, and it has a conjugate 5 minus 12j. So you can see here's our method here that we defined, conjugate, and it returns a new complex number that's got the same real number and a negative of the imaginary number, the imaginary value. So you'll see when you're defining these functions, we pass in an argument, just like you would in any other function. And the first argument, when you're looking at a method in a class, it should be self, when it's one of the object methods. So that way it will use, it's got a reference to the value that it needs to work on. So if we say d.conjugate, then d becomes self and it gets put into the parentheses. So then it's like d.real and minus d.imaginary. So that's why that self is there, even though, and then when we call it, we don't have to put anything in there because we've put the d out the front here with the d, with the dot. And I found that a little bit confusing when I first came across it, but it works surprisingly well. So I'm happy to go along with it. We can look at all the attributes of D because it's an object. We can call _dict _on it, and that will give us a dictionary of the attributes. And so we've said, we've printed here attributes of D of type. And so what's our type? Our type is main.complex, as opposed to just complex before. And the attributes, we've got an attribute real, which has a value 5, and an attribute imag, which has a value of 12. Now this main, that's what Python calls the Python script that you're currently running, that you've written yourself. So if it says _main, then that's your own script, and that's why you and it was, the program was launched from that script. If it's got another name, then it's been called from another script somewhere else, and that's how you can tell if you're in the script that's been called. But we define complex in main, and so that's why it's main.complex. We've got the attributes, print, and okay, so this is we did the attributes here of the object, but the class itself also has attributes. So we can say the class name, which is complex, and look at our dictionary of the attributes in complex. And you see there's a few more things here. So these are things that our object has access to, all of these functions that they are in this case, and attributes, well, I guess, yeah. So that's why we can use _dict on our object, and it will give us all the well, it is an attribute, and it's a dictionary of all the complex objects, and this will return the attributes in there. There's other things like doc and init, which we'll go over later, and str. All right. Well, we should do init first. So if we go back to our class that we created up here, and there's our init, and init is our constructor, which means that that's what gets called when we do complex and then open parentheses and put in some values. So we put in a real value and an imaginary value, and it comes with self because that's what gets constructed to create our object. So then we can assign the real attribute of self with real and the imaginary attribute of self with imag. So that's the clue you need for the first challenge that we're going to do. I've got you a task here. Task 1, create a class invoice which takes parameters. I'm going to go do it now. You can either pause the video and have a go at it, or just work through it with me. So we want to create a class. So the first thing we do is type class. The name of the class is going to be invoice. So we type invoice, and AI's jumped in there and gone, that's probably what you want. So I'll do that. Generated code may be subject to a license. There you go. I haven't seen that before. All right, and that's our source repository where we store all our code, and the link I gave you up above was for a mirror of that. Okay, now in our class of invoice, we want to create a constructor method. So we define our function, and we're going to do init, and it's gone ahead and done all the work for you, but our init's going to take our 3 parameters, which was AUD amount, days terms, and date of document, and store them into attributes. And that's pretty much what we want. So let's press tab and get all of that. And remember, the self out the front gives us a reference to the constructed object that we can then store these attributes in. That's pretty simple. We just run that, and there's our class. So now I'll run you through a solution that does pretty much the same thing, but it shows a few extra features that we can do when we're defining a class. So we start off pretty well. We give the name of our class is invoice, and then you see we've got this multi-line string here in this this triple double quotes, and that's where we can put our doc string. So if we put this data in here, makes it really easy for people using our class later on. They can hover over it, and it will tell you what's needed to create it. We need an Australian dollar amount, number of days before payment of invoices due, and the date the invoice was issued. We're going to have one method, which is the due date, so that once you've got an invoice, we can call that method, and it'll tell us what the due date is, which will be the date of the invoice plus the number of days before payment is due. So here's our double underscore init double underscore. It looks pretty much the same, except we've put in some default values here for a couple of the parameters. So we said we're going to default to 30 days terms, and the date of the document we're going to default to just none. So really someone could create an invoice just by providing the Australian dollar amount of the invoice. Once again, in each of these functions we can put a doc string, and in this case we're just saying this is our constructor. We're going to set the amount and the number of days terms, and that'll put in 30 if nothing was provided, or if something was provided, then it'll put that value in there. Now for the date of the document, if none was provided, then it will call this function here, datetime.datetime.today, and put in today's date. So that's pretty much what you're going to be wanting on when you're creating invoices. It'll always have today's date on it. So that's pretty easy. And then date due, we'll say, given a reference to ourselves, what's the due date? Well, it's just going to look at the document date, and it's going to add in a time delta of the number of days, which we've stored in self.days terms. So I can easily create an invoice just by going invoice 350, which will be, so that'll be the value of the invoice, and then I can print it out, and it'll tell me what the I'll look at what the value of the invoice is, what the date of the invoice is, and what the due date is. So let's run that and see what it comes up. So an invoice for $350. It was dated today, the 18th of June 2025, and it's due in 30 days, which is the 18th of July 2025. So you see how we've called this method here. We've got our object IV that we created by saying invoice 350, and we just put the function name or the method name after a dot and parentheses to say we're calling it, and that returned the due date. We then formatted it. Okay, so that's one way of doing it. The other way, you could actually call it as it was written, which means providing the self argument. You provide that. So the way to do that, rather than calling it on the object like we did there, you call it on the class. So you can say invoice.dateDue and then say I want to run this function using IV as the parameter. So they should both give the same answer, which they do. So there's two ways of doing it. Most of the time you'd use this first way, but very occasionally there may be some reason why you'd want to do it the second way. Alright, task 2. Add a string method to the class so that it's easier to print the invoice. Okay. Now because these functions have to be inside the class, I've got to put this all, I've got to redefine the whole class. This is not normally a problem because when you're writing Python code, you just go up there and edit this in place. But because we're in a Jupyter Notebook, I could go back and edit it up there and then rerun it, but I'm going to copy and paste it here so that it's we're just continually moving through the notebook, and you can go back to look at the early stuff if you need to refer back to it. So we want to create a function str, and it's going to create a string, and I may as well just use this f string that we had. We don't need to say solution 1 because it's no longer solution, it's not even solution 1, so I'll get rid of that. Okay, and now rather than say print this, I can just say print my invoice and it will print the whole lot. So let's run that and see. So IV equals invoice 350, and now I print it, and it prints this is an invoice for $350 dated the 18th of June and due the 18th of July. Okay, so here's the solution, and another way of doing the solution. Once, like I say, you wouldn't do it this way normally, but I'm showing you it's possible to do it, and because of the way we're working through this Colab notebook, it makes it a bit easier to do this rather than having to copy and paste everything that I just did up there. We just define a function, string invoice, that does what I want to do. I've got a parameter going in there, self. It could have been called anything. But because it's going to become a method, self's a good word to choose, and it will help people reading your code understand what you're doing. And then once I've created this function, I can assign the function to this attribute here, _str, and then it can run it. So the problem is it's exactly the same as what I've just created, so you're not going to be able to see if it's done anything. So let's change this one to invoice, we'll just say invoice value, this much, dated that, due that. We'll get rid of the is. There we go. And we'll throw some commas in there. Alright, so we get a different string. And let's run that, and so you can see how I've created this. And oh yeah, so solution 2 it got printed there, and then I just used an f string for IV, and it's printed invoice value 350, comma, dated 18th of June, comma, due 18th of July. Now that was just a one-line function. Sometimes in Python, if you're just doing one-line functions, you can use lambda rather than define it in there, because it takes 2 lines to define a one-line function. But if you really want to define it all in one line, then you can use lambda in this way. It's not really a part of object-oriented programming, but I just thought I'd throw that in to show you how to do that. if you're interested, I can go through more on that. So that's using lambda, does the same thing, and we've gone back to a similar string to what we started. Okay, task 3, create a class for quote. So we've done invoice, now we want to do a quote. So it's got values for amount, days valid, date quote, and method date valid too. So that's sounding pretty similar to our invoice. So why don't I just copy and paste? Okay. And we'll paste this in here, and we'll call it quote now. Of course, when you start copying and pasting code, that's usually a red flag saying you shouldn't be doing that, but that's what we're going to do for now, and then we'll see if there's any other ways of doing that. Well, we'll get rid of that because that's no longer the case. We're going to have an amount, days, we won't have terms, we'll have valid. And date quote, which was called date document, that's fine, and a method date valid too. Okay. You have to call that the same thing, and so we may as well call where we store it the same. And date document is okay, AED amount's okay. I'll get rid of the comment for now. And our string, it's a quote, and it is valid too. Oh, I did a mistake up there. I should have used self here. It worked, but it shouldn't have. It worked because my invoice was the correct, was the same as self, but that should be self in all of those, and that should be date valid too. Yeah, so if you want to go back and fix this one here, they should be self. I don't need to rerun it because we've already replaced it with this other code that did use self. So we'll create a quote, and I'll store it in a variable q, and it'll be for 1,350, and then let's print it. And it's not even a constructor, so I'll get rid of that. It's not even an invoice. Document days valid. There we go. I'll fix this. Days valid. So it's a quote for 1350, dated 18th of June, and valid for 18th of July. Okay, so that's one solution, but you saw that I was copying and pasting a lot of code, and when you do that, one of the principles in programming is don't repeat yourself, DRY. So if I'm copying and pasting, then I'm repeating myself. So what's another way we can write this without repeating ourselves? And what we can do in object-oriented programming is we can use inheritance. So all the stuff that's the same between those two objects that we've created, those two classes, we put them into a single class called document, and then we inherit document into two subclasses, one called invoice and one called quote. So we're going to do a little bit more work because there's a couple of differences in the code. For example, I've got here is valid to for the quote and is due for the invoice. So we'll store that in a variable called an action. We're going to need to know what sort of document it is. So we'll store that in the document type, just a string. And when I name my attributes, I like to just put a hint at the front to remind me what type it is. So I've put str, say it's a string for the doc type, and a string for the action, AUD for the amount, so it's Australian dollar amount, date for the document date, and days, so that's a number of days, duration. So that can be days valid or the days in terms. Date duration is a method on this, what we'll call a superclass, and the subclasses inherit from it. And it's just the document date plus whatever days duration we've stored. And we can create a string which is based on the doc type and the amount and the date, and there's our action, and finish. Alright, so now we've created that, we can inherit off that class into this class. So now I'm saying I want invoice to be of type document with a couple of extra features. So if someone initializes or instantiates a object of type invoice and they give us these three pieces of information, I'm going to call the superclass, which is document, and say it's going to be an invoice. The action is going to be payment is due, and the amount's the same, days terms. I'm going to pass into the days duration parameter, and date document I'm going to pass through. It could be none, in which case it'll get defaulting to today's date. And then I've got a date due, which is just calling date duration, which everything that's available here is available here to the subclass invoice, and it's also available to the subclass quote. So let's try running that and creating a quote and see how it works. And there we go, solution 3 with inheritance, quote for $346, dated this and due on the 2nd of July. So yes, we've noticed the days valid is defaulting to 14 days for our quote, even though our terms were defaulting to 30 days. So that's why it's now the 2nd of July. Alright, so that's writing the code without repeating ourselves. So it's a better solution. And in fact, it's so good we can now extend it even further. We can create a sales order class. So that's basically says we have a days that we want to deliver when the goods need to be delivered. So this can be defined just here, or it can be defined in a different file. You can subclass. You don't have to subclass in the same file as the superclass, and you can even subclass built-in classes from Python. So let's try sales order. We're going to amount, days valid, so we want days deliver, and we'll default to 7 days, and our document date, so we'll call it a sales order, and we're going to deliver it by. And we want to know date deliver by. So we could call that method if we want, but in fact for our printing it's going to be using the superclass method date duration. So and we should create an object. So you see how the indentation here, everything inside the class is indented. Now I'm outside the class, I have no indentation. We'll create our sales order. 1, 2, 3, 4. That looks good. We'll run that. Solution 4, sales order for $1,234, dated 18th of June, delivered by the 25th of June. And we look at the solution provided here. We can see that the AI has been cheating and looked ahead because it decided the sales order was going to be for $1,234, and that's exactly what I'd put in the solution. The solution's got a bit more of a doc string here for date deliver. I call it date deliver by. We'll just make this the one, so it's date deliver. There we go. Any questions on this? It's really powerful functionality, and it actually is also really good at compartmentalizing all the things. Everything you want to do with a sales order, you put with a sales order. Everything with a quote, you put with a quote, and then anything that's common across a few things, you put in the superclass. Okay, task 5. Create a class item which can represent a line item on a quote, sales order, or invoice. So it needs a description, quantity, and a unit price. Well, remember how easy it is to create a class? You just say class and then the name of the class. So we'll call it item. And we're going to have 3 things: description, quantity, and a unit price. And we'll just store them in attributes for our object. Now it's gone ahead and looked ahead because I can see it's used the same variable names that I've used. So let's just accept the AI for that. I can see why they're saying it may be subject to a license, is because they got it from our other code. Okay, and we can run that. Doesn't do anything at this stage except define the item, and we could then use it. So let's look at the solution. Solution is the same. We've got the constructor in there that creates our object, and it's then ready to use. But we're going to throw a couple of extra methods on there. So AUD cell is going to extend the unit price. So it's going to multiply the unit cell price by the quantity and get the extended price. So if you buy 3 things at $4, it'll say the extended price is $12. Okay. We've also got we've put a string method in there so that we can display the output in a slightly formatted way. So and we're going to have a class attribute called string title. And so by being a class attribute, it's going to be, for every item in the class will have this value. So there's a advice there not to use mutable values in class attributes. So don't use lists, for example. But strings are fine. Strings are immutable. All right. Now we're going to create a function that will add the items to the other objects, the documents, so they can be we can have these line items on our quotes, on our invoices, or our sales orders. And so we'll just create this function. All it does is check if there's a list of items already there, and if there isn't, then it will create an empty list. Otherwise it'll just add it on to the end of the list. And then we modifying the class on the fly. This is not the way you'd normally do it, and if you look right to the end of the code, I've done it in the way that you would normally do it, but I'll just, because we're working through a notebook here, I'll just add that that method into document. Alright, so it's there. let's add a couple of items and print them out. So we've got our quote, we're going to add a thingamy and a doodad. So we've got 2 at $123.45, that comes out to $246.90, or we got 5 at $34.60 and $173. So if you think about how just what the amount of work that you would have to do this in another way, you would have to do a lot of repeating yourself, but because we're doing it with objects, we're getting a lot of reuse out of our code. Okay, task 6, create a report in document for all documents. Okay, so we want to create a method that's going to basically print out an invoice, or print out a quote, or print out a sales order. So I'll just do a quick one without any formatting, just to see how we'll do it. So we'll go document, report. So it's going to be based on self. So this is going to be in a document class, so it's going to be in the super class. And we're going to we're just going to print out the, what do I want to do? We're going to print it. I'll do printing. Self dot string doc type, and we'll do the date. Date document. We don't need to do the due date. And then we'll go through all the items. And then we'll print out a total. Well, in fact, it's really just the other costs. All right, we'll assign that into our document. And what do we call it? Report. Yep, that's probably a good name. Equals document report. And let's try running it. So in this case, we'll take our quote and we'll run that. And there we go. It's printed out our quote, the date and time, in fact, and all the items and the other costs. All right, so that's a quick report of the quote. Let's have a look at the solution. And we'll see that we'll just run this solution, and it's got a lot more formatting in it. So it's given us all these things like valid until. It's given us some headings for our items. It's taken the AED amount that was in our original, and we'll assume that's other charges like freight and stuff like that, and added to the cost of all the items, and that's given us a total for the whole quote. And it's done it. So this one's done it as a string, and then we have to print out the string. So that's probably a better way of doing it too. All right, so let's have a look at inheritance for our objects. So we look at our quote, our sales order, and our invoice, and we're going to see how isInstance works. So remember, we've got a quote for $346, and we're going to check whether it's a document, a quote, a sales order, or an invoice. So is it a document? That's true. Is it a quote? That's true. Is it a sales order? That's false. Is it an invoice? It's false. So you can see it can be of different types, and this is the advantage of using isInstance over checking a particular type. Because if you want to know if it's a document, then all quotes are going to be documents, so they'll come up true for documents as well as quotes. So you can check if it's some sort of characteristic of that object that you're interested in that's common to all sorts of documents, then you could do is it an instance of document. But if you specifically want to know has it got the characteristics of a quote, then you can do is it a quote, or is it a sales order, or is it an invoice, one of the subclasses. So that's how the inheritance works and the isInstance function works. Similarly for sales orders, that was true for sales order and document. Now I've put the invoice in here, but remember we created our invoice early on before we did the inheritance, so it's still got the original type that we created, which is false. It's false for being a document because it wasn't a document, it was just a straight invoice that we created. If we created a new invoice, like this one here, IV2, let's create it, and there's our new invoice. If I go back here and we check, well, let's put IV2 in the list. And this one's is based on documents, and so that's come up true for the is instance of document. Have to create because did not inherit document. Exactly right. Task 7. Add a method to invoice so users can check the value of days terms without having to know the subclass name days duration. Okay, so if you want to look at the days terms for an invoice, if you remember our structure for invoice, I'll go back up to here. It just uses the days duration attribute, which was stored in document. So if someone's working with an invoice and they want to know the terms, they're going to, they probably won't remember days duration so easily. So we want to add another method in here that they can get the days duration out. So let's go back to that task, and we'll create a function, and it'll be for invoice days terms, self return self.days duration. Yep, we got that all right. And then we can assign to that function in invoice to our function we've just created, invoice days terms, and we can try running it to see if it works. That worked. I would have thought we would need to put yeah, so that was that worked because it was using the original invoice that we created. So let's run this. IV2 days terms equals 30, and so that's correct. So if I tried IV2 days terms without the parentheses, it will just give me a bound method on that object, because that returns the function without actually calling it. So I want to call it, so I have to put the parentheses in there. So here's an alternative way of doing that. If we want it to work without the parentheses, then we can create what's called a property. So we take our function and we put this decorator on front. So anything with an @ symbol in front is called a decorator, and it modifies the function behind the scenes in a way that where you get to know what each of the different decorators does. And this one means that we can then call IV days terms without using the parentheses. And there it is. That's working. So creating a property like that, it makes it look like an attribute, but it runs a function every time you call it to return the value. Now we can try setting the value the same way, but it will come back with this error: property of invoice object has no setter. So you can see I've gone iv.days to days terms equals 35, and it doesn't work. So the solution for that, there's another decorator that will make that work. So I could, no, we'll just go straight on to this and use the decorators because that's the easy way of doing it. And this is for quotes. So we do the property lets us return a value, and then we can use the same method name in a decorator and put .setter after it, and then it will take a function and use the next function, which has to have the same name as that property, to be the setter. So I can now assign values into that. So if I say I want days valid to be a number, it will store it into days duration. And there we have solution 8, q.days valid equals 14. After the change, q's.days valid equals 21. So we set it to 21, and then we checked it again. So the advantage of this is it means that you can start using attributes for setting values in objects right from the start. Now, if you come from the Java world, in Java they try to get you to make all your variables private, so that people don't accidentally change them, because often you'll want to add some functionality in later when a variable is set. So like if an extra item is added, you might want to recalculate the total for the invoice or something like that, which you may not need to have done in the early days. So in Python, you can still do it as a attribute and then convert it into a property and a setter property, so that when they assign a value to that attribute, it runs a function which can do some extra little things that you need to clean up the data. All right. So now I'm going to cover just a couple of advanced topics, just to let you know they're there. I don't expect you to understand them fully. And in fact, I wouldn't remember them off the top of my head either. But it's just good to know that they exist. When you're naming your variables, you can name them just normal variable naming, or you can put a single underscore out the front, or you can put a double underscore out the front. And the convention is that if it's got no underscore out the front, then it's a public class variable, so feel free to use it in your code. Just directly access that variable. If it's got a single underscore, the convention is it's private. It will be still available to be used if you really need it, but the recommendation is don't use it, because it might the behavior of it might change sometime in the future. So that's how you tell other people not to use your private class variables directly. If you put a double underscore on it, then it does some things called Python name mangling, which allows you to have the same variable name in subclasses that won't make it impossible to access the value in a superclass. So I'll probably just go with that for now, as we're running out of time. So we'll just run this and see what the output is. So we've got some values. We've got class values, which were these ones up here, and we've got class values. We've got instance values here. So these ones have got the same name as the class values. These ones have got a different name to the class values. And then I've got methods that can return those values. So I've called them dunder for double underscore and sunder for single underscore. So I create a value using my base as our class, and we run them all, and when we look through the data, we see if most of the things have just come out okay. When we looked at the object, it has no attribute double underscore my1. If we looked at the class, it also has no attribute double underscore my1. But we can refer to it by putting the class name with a single underscore in front of the double underscore name, and we get my double underscore dunder class variable. And that's referred either as the object or the class. And remember down here, in the advantage of doing that with my2, if we refer to it as an object, we get the value stored in the object. If we look to it from the class, we get the class variable. So that's a way of seeing that. It doesn't get hidden. And similarly, when we go down here, we create a subclass, my sub, and now we can actually, and let's just run this. And from the subclass, we can refer to the superclass and get values out of that. And you can just, if you work through the code, you'll see what all these values mean. But yeah, it's mainly if you're doing inheritance, but you don't want to lose access to some of the code in the superclass. All right. Other things possible in Python: multiple inheritance. You can't do that in Java. So you have a couple of superclasses can be joined to make a subclass. If you've got the behavior of two different superclasses you want to merge together, that's a good thing to be able to do. Let's just run that. And oh yeah, so, and here's just some design patterns. If you're making subclasses and you want it to make it use in multiple inheritance easier, then you capture all the keyword arguments and then pass through the unused ones. So for example, if I put in a single named argument here and then capture all the others into a variable called ** keyword args, it could be called anything, but it would have the 2 stars there, then whatever gets passed to it, if there's a parameter there called key1, that'll go into this variable, and everything else will go into this dictionary, and you can then pass that dictionary on to the superclass, and it can do whatever it wants with that. So that's just a good design pattern. And then finally, to finish off, we've got the how you define the class document and all the subclasses if you were doing this in a single script. And that's what you would normally do, rather than how I was assigning functions and modifying classes after they'd been defined. So I hope you found that useful. We've got one guy who didn't find it that interesting, but if he thinks he can do a better job, then we are looking for presenters, especially if you're in Brisbane. We're looking for people who can present, especially machine learning topics for our in-person meetups, and he's also welcome to do a meetup in part of Beginners Python Machine Learning online, if I'd like to do that. I hope you enjoyed it. I hope you learned something. Try to use classes where you can. It's will make your code easier to manage, and makes it easier to work in teams with other people who are all working on the code together. Thank you.